Alright students, so we're now here in the iBook, last part of the guided notes today, and we're just going to work through 5 problems. Alright, first problem, which of the following statements is false based on the figure below? So we got this triangle. Let's just rattle through these problems till we figure out which one's the false one. Alright, so let's look at A. It's claiming sine A equals 4/5. Alright, well, let's look at the actual triangle. Alright, angle A. So, given angle A, remember sine A is opposite over hypotenuse. The opposite side's 16. The hypotenuse is 20. 4/5. It checks out. Alright, so it's not A. Let's look at B. Tangent of C equals 4/3. Let's actually solve that. Tangent of angle C is going to be opposite over adjacent. Now opposite side's 12, adjacent side's 16, and that reduces to 3/4. So that's the false one. Alright, false. So number 1, B is false. Cosine of A equals 3/5. That would have ultimately been true. Moving on. Alright, then that was number 1. Number 2. Another, which one's false? Alright, so sine of angle A, opposite over hypotenuse, 9/27 equals 1/3. That's true, so we're going to move on. Cosine of angle B is going to be adjacent over hypotenuse. So one thing I forgot to mention is that when you swap like angle A and angle B, sine and cosine, those trig functions are the same. You might have realized it in example 1 and 2 in the last video. So that's also true. This one throwing us for a little doozy, saying tangent of angle B equals opposite over hypotenuse equals, well, we don't know the opposite side, we know adjacent's 9, so really fast it's going to make us use Pythagorean theorem. So 9 squared plus the opposite side squared equals 27 squared. So we're really starting to know so much about triangles. We got Pythagorean theorems, special right triangles, now we're adding trig to our tool belt. So much stuff. And I gotta use a calculator for this stuff. This is intense. Okay, I got a little thinking to do. 648. I'm almost there, just give me a minute. Ooh, see, sometimes us teachers take a while to find the largest square factor. So this is actually going to break up into 3/24. Okay. Took a lot. This problem's actually kind of hard. Radical 2, which clearly is 18 radical 2. Okay, so that's the opposite side. So then I can finally plug it into here. So opposite's 18 radical 2 over 9, so 2 radical 2. So it appears all these statements are true. That one was tough. Alright. Hopefully number 3 isn't that tough. Another false one. whoever the heck made these false problems, all right? Too many of them. Which one's true? I want to do a problem like that. Number 3, all right? So realize really fast, I'm going to just draw a really crappy picture. All right, since we know one of these angles is 45, that has to be 45, so that's 4, and then that's 4. It's the right isosceles we were talking about in previous notes. This is a 45, 45, 90 special right triangle. So now, looking at this, sine of angle A, opposite over hypotenuse, is going to be 4 over 4 radical 2, which is going to reduce to 1 over radical 2. And then you just got to rationalize the denominator. Radical 2 over 2. So, at least this time, we found out that A was false. And number 2, we forgot to write. They were all true. Alright, so in this problem right here, tangent of B would actually be 1, cosine of B would be radical 2 over 2 like we just found for sine A, so on and so forth. Alright, if a triangle ABC, in triangle ABC, angle C is the right angle. Alright, so let's just draw this one really fast. This is number 4. So our pictures never have to be that beautiful. It just says we have some triangle and C is the right angle. Cosine of B, so this is a really good problem. Cosine of B is 40 over 41. So realize that this cosine is adjacent over hypotenuse. So with respects to angle B, that means 40 is the adjacent side, hypotenuse is 41. Alright, now it's saying what's the sine of angle A? So sine of angle A is going to be opposite over hypotenuse, which is going to be 40 over 41, because this side's opposite, that's the hypotenuse. Boom, nailed it. A little fun fact too, this has nothing to do with the problem. This side's 9. A weird fact is 9, 40, and 41 is a Pythagorean triple. Alright, 9 squared plus 40 squared equals 41 squared. I always find that weird. Those numbers don't look like they'd form a right triangle, but they do. That's just a little fun fact of the day. Alright, and then the last problem, hopefully this one's not too challenging. We've done so much trig today. Number 5. Alright, again, we got some triangle, ABC. Alright, C is the right angle. Tangent of B. So tan B is radical 3 over 3, which is opposite over adjacent. So with respect to angle B, opposite side has to be radical 3. This side has to be 3. Okay. Now it's saying, what's the cosine? It's asking, what's the cosine of angle B, which is going to be adjacent over hypotenuse. So adjacent, hypotenuse. Alright. So basically what we have to do first is Pythagorean theorem. Hopefully it's not going to be too crazy. We're going to have to do radical 3 squared plus 3 squared equals the hypotenuse squared. Radical 3 squared is 3, 3 squared is 9, h squared equals 12, h equals radical 12, radical 4 over radical times radical 3, h equals 2 radical 3. Alright, so now we can plug all this junk in there. We know adjacent side's already 3. We know that's 2 radical 3. Now we gotta rationalize the denominator. This is the problem that never ends. 3 radical 3. 2 times 3. These 3's obliterate each other, and we're left with radical 3 over 2. What? This problem, what, 1/2? There is a typo in this one. Alright, typo, should have been radical 3 over 2. We'll live though, we'll forgive the iBook. Alright, don't worry too much. And that's it for this video.